Dear student, welcome to my channel. Topic of this video is multiplicative inverse. Now let us start. The multiplicative inverse of a number a in given modulo n denoted as Zn is a number b such that a into b is congruent to 1 mod n. A multiplicative inverse of a modulo n exists if and only if a and n are co-prime to each other, that is nothing but their GCD is 1. For integers, the multiplicative inverse is not always positive. The inverse can be any integer that satisfies the above equation. However, it's common to represent the multiplicative inverse as a positive number within the range from 0 to n minus 1. Now we'll solve some of the problems on multiplicative inverse. First problem, find the multiplicative inverse of 3 in Z7. We can represent this problem like this. So Z7 is nothing but our n modulo n, 3 into b congruent to 1 mod n. Now we require to compute the extended GCD of 3 and 7. The extended GCD of 3 and 7 is equal to 3 into 2 plus 1. This 3 will come here, this 1 will come here. 3 is equal to 1 into 3 plus 0. We are not taking this equation for back substitution. So 7 minus 3 into 2 is equal to 1. Here 7, 3 and 1 are variables, while whatever quotient, they are always in bracket and they are nothing but the coefficient. Now here with respect to 7 the coefficient is 1 and with respect to 3 the coefficient is minus 2, but we always prefer the answer in a positive form. So b is equal to minus 2. We always take again the mod to get the positive value. So minus 2 is equal to 7 into minus 1, because our base is 7. 7 into minus 1 plus r. So this number always less than or equal to this number. So we can't take 0. So it is 7 minus 1. So minus 7 is small than minus 2. So answer is 5. And 5 into 3 is 15. And when we divide 15 by 7, then our remainder is 1. Next, find the multiplicative inverse of 2 in Z25. So here we write 2 into b congruent to 1 mod 25. We will calculate the GCD of 2 and 25. 25 is equal to 2 into 12 plus 1 and 2 is equal to 1 into 2 plus 0. So we will not take this equation. So this equation we can arrange as 25 minus 2 into 12 is equal to 1. So here with respect to 2 our variable is minus 12, because we require with respect to this 2. So minus 12, again we want the positive term. So minus 12 is equal to 25 into minus 1 plus r. Remainder is equal to 13. And 13 into 2 is 16. And when 13 into 2 is 26. And when 26 divided by 25, the mod will be 1. Find the multiplicative inverse of 8 in Z19. 8b is equal to 1 mod 19. We will compute the extended GCD for 8 and 19. 19 is equal to 8 to the 16 plus 3. This 8 will come here, and this 3 to the 6 plus 2 8. Then this 3 will come here, 2 into 1 plus 1 3. Then this 2 will come here, this 1 will come here. Now here we are not taking this equation in the backtrack, so we arrange this equation. So this equation is arranged as 19 minus 8 by 2 is equal to plus 3. 8 minus 3 by 2 is equal to 2, and 3 minus 2 of 1 is equal to 1. So we take this equation. So we are taking the substitution by the reverse way. So we will take this first equation, 3 minus 2 of 1 is equal to 1. Now here we require to substitute the value of variable. So here in bracket are all coefficient and without bracket are variables. So now here we require to put the value of 2 and 3. 2 and 3 are variables, but we will go step by step. So first we will put the 2. I have already published the video on extended GCD, so you can check that video for understanding such type of problem. So we will replace with 2. 2 is 8 minus 3 by 2 plus 3 by 3 into 2, and the coefficient is 1. But when we multiplied x with 1, it does not make any change. So that's why the coefficient 1 we can ignore. So after arranging the equation we are getting this. Then 3 1 and 3 2 times it becomes 3 3 minus 8 of 1 is equal to 1. Now we replace this 3 as a variable value, which is 19 minus 8 of 2, and the rest of the equation. And after solving we are getting with respect to 8 variable is again minus 7. So again we will take minus 7 is equal to 19 minus 1 plus r, which is equal to 12. And when we multiply 12 into 8 and when we divide this number by 19, we are getting the mod 1 as an answer. Similar problem you can just try to understand. This is the GCD step. This is the preparation for extended GCD. We will take in a reverse way. We will arrange, and with respect to 7 we are getting the coefficient 2. So 7 into 2 is 14, and when 14 divided by 13, our remainder is 1. You can check how these steps are arranged. Final example. Find the multiplicative inverse of 4 in Z9. We will calculate this. Now we can see that we are directly getting the answer. With respect to 4, minus 2 coefficient is there, and we want that only. Minus 2 is equal to 9 into minus 1 plus r is equal to 7, and when we multiply 7 4 is 28, and when it is divided by 9 we are getting the remainder 1. So in this way, by using the extended GCD, we can find out the multiplicative inverse, and which is required to solve the cryptographic problems in cybersecurity subject. Thank you.